Okay, so let's get started with another problem. This is number 3 on the chapter 15 review sheet. In this case, we're given a chemical equation, the SO2Cl2 breaking up into SO2 and Cl2. It's like a decomposition. At 100 degrees Celsius, our Kc value is given to us. And in an equilibrium mixture, so this is at equilibrium, it turns out that we have our concentration of our SOCl2, and we have our concentration of our SO2, and they're asking us for the concentration of Cl2. So basically they're saying, can you relate the equilibrium constant to the Cl2 that we see there? Okay, so just as a recap, hopefully they're getting the hang of this, but the idea is that Kc, remember that our value for, our Kc value has we represent it through the equation of the products over the reactants, so SO2 and Cl2 all over SO2 Cl2. And the idea here is that all of the values that go in this equation, all of these are all, even this guy, are all equilibrium concentrations. I can't stress that enough. So if we imagine this, we have a reaction that goes forward, and then at some point this reaction is going to reach equilibrium. And when it does that, then each of these reactants and products will have some concentration. And the concentrations at equilibrium are the values that we will put into this equation. So these are all equilibrium concentrations. And that's vital, right? Okay, so then right now we have a, let's see, we have a Kc value. So, they give us the value for Kc. So they give us this. They give us the concentration of SOCO2. And they give us the concentration of SO2. So the only thing we need to solve for is the concentration of Cl2. Okay, so then all we got to do essentially is rearrange this equation, and then that will allow us to solve for this problem. So okay, this seems like a pretty straightforward problem because you're just rearranging variables. However, what you need to realize is that you have all of the information you need to solve for this, and you need to make the connection that the Kc, the equilibrium, those are all equilibrium concentrations that go in them. Okay, so let's do that. So then I want to solve for Cl2, so I'm going to rearrange my Kc equation. So I multiply both sides by SO2 Cl2. So I'm getting rid of that denominator, and then I'm going to divide both sides by SO2. And I'm just going to, because I have the tablet, I'm just going to do that. So this is a rearrangement of the original equation to get this nice equation here. And then all I got to do is plug in my values for Kc and all the other concentrations to solve for the equilibrium concentration of Cl2. So kind of great that if you know the equilibrium constant and you know the concentrations of the other reactants, you can solve for the remaining constituent of the reaction. So Kc in this case had a value of 0.078. 0.078 multiplied by SOCl2's equilibrium concentration of 1.136 divided by 0.072. That will give us our Cl2 equilibrium concentration. We just got to plug that in. 0.078, 0.136, all over 0.072. And if we do that, we get 0.147, repeating. If we accommodate for two significant figures imposed by this right here, well then our answer would be 0.15, which is equal to our equilibrium concentration of Cl2. Alrighty, so this is just kind of showing you what's possible if you have, remember, so we can kind of think of it like this, right? This is just a normal equation that you can rearrange that we've done a million times in chemistry, right? If you have an equation and you know 3 out of the 4 variables, well, you can rearrange to solve for the last one, right? So this isn't necessarily imposed by it just being Cl2. It could be any of these other reactants, or even the Kc value itself, right? That's what we did in a previous problem with ice tables, right? If you have each of these, you can solve for Kc. Alternatively, if you have 2, for example, and Kc, you can solve for the remaining one, which is what we did in this reaction, or this problem, rather. Okay. Hopefully pretty straightforward problem. I hope you guys are kind of getting the hang of this guy. Just make sure that you're doing these problems and attempting them before you watch the videos, okay? So, I will see you in the next video. Thanks.